I've gotten to the part of grad school where everyone wants to know, so what's next? And the most common interview question I've been getting is, where do I see myself in 5 or 10 years? And some days I wish I could say that I think the more important question is, well, where do we think our planet is going to be in 10 years? Global food security is going to be challenged in the near future because of a rise in population and the effects of climate change. Scientists estimate that by 2050, there are going to be nearly 10 billion people on this planet, more people than our current food production systems can feed. And today, 95% of our food is grown by healthy topsoil, the first few centimeters of the ground that you see behind me. Unfortunately, this planet's topsoil is being degraded at an alarming rate because of unsustainable farming practices. And if nothing changes, 90% of this planet's topsoil is at risk of being completely degraded by 2050. And to put it lightly, these numbers, they're not very good, and these statistics can cause a lot of fear and anxiety, but wherever there's fear, there's hope. And this time, hope comes in the form of those that dare to answer the question, so what is next? Agriculture may look a little bit different in our future than this photo behind me, and that's okay, because one alternative will be the rise of at-home gardens. Unfortunately, this option may not be possible for those living near polluted soils, because heavy metals like lead from industrial activities have settled into urban environments over time, and not just in the air and the water, but in the soils. And studies show that certain plants grown in these polluted soils can actually intake lead at levels that are unsafe for human consumption. But trying to remove these heavy metals is an expensive and complicated process. So what if instead of trying to remove them, we find a way to immobilize them, or letting them stay in the soil but decreasing their threat? My thesis work focused on making biochar, a charcoal-like material that you can mix into the soil that's made by burning plant or animal waste at really high temperatures without oxygen. Biochar works because the heavy metals in the soil have a positive charge, and the surface of biochar is negatively charged, so opposites attract. Not only that, biochar has a large surface area, so a lot of heavy metals can stick to its surface at one time. And the biochar I make is from common food waste, like citrus peels and almond shells, making this not only eco-friendly, but a cost-effective option for helping these polluted soils. Biochar has also shown to increase crop yields and improve overall soil health. So have no fear, because biochar research is here, and this soil amendment has a very promising future for increasing our global food production and making polluted soil safer all around the world. Thank you.